like for example, this missing sum of squares error value.
Yeah.
And you might, from the information given, maybe it's in words, you may have to find the degrees of freedom total and then calculate degrees of freedom error and so on. How comfortable are you recalculating this table with missing
So
values?
we went through some of that in class today.
Okay.
And so I had like not that comfortable, but I'm starting to understand more. So like with the in the means for one-way ANOVA table, the one number under mean,
This,
3
this one right here.
mean, no, in the table below,
Okay.
that one, like that's something that I can like easily do. That's just taking averages. When it comes to finding like the like root mean square error, and more complex things, like even just like the first question, what's the estimate of the standard error of um
Mu. Yeah.
mu
Yes.
not, like that we went through it in class, so I know how to do it, but I don't quite understand it.
Are you given a formula sheet for this class?
I believe it's open note, so like yes.
Okay. Do you have a formula that you like for this?
Well, with that one, so taking like using the standard error of X bar is the standard deviation over n.
Hmm.
But then for this, we would use the root mean square error. And so to
Yes.
find that, then taking, so wait, why? I'm just like reading what my teacher did for this one. Why is it root mean square error?
Uh,
In place of standard deviation.
it's a function of the ANOVA. These are the these all have meaning in the ANOVA. I guess I should say start out by
Okay.
saying that. That's why I was asked, because every class is a little bit different with how they present this.
Yeah.
Some are very formula specific, and that's why I'm asking, because you're right. It is sigma over the square root of n, but what is sigma in your problem? They're in this table. How do you know? Um, it can, because you can also be similarly asked questions for um, like the standard error of the variable and then the error. Um, that's why I'm asking for a little help here to because I can go out
Yeah.
and find some equations, but I want to make sure it's the ones you guys are using. Do you have any?
So what, yeah, so for that, then I have like root mean square error, then taking the square root of the mean square error, and the mean square error is the SSE over degrees of freedom, the root of that. And so then that would be the like the SSE is the total sum of
That's
squares.
yeah. It's this missing one here. This is
Yeah.
SSE right there.
And then over the like degrees of freedom.
Yes, that's how you get the mean square
Yes.
MSE.
And then you would put that over root 17.
Why 17?
That
It's
I'm
not.
unsure
I
because
because I feel like I thought it was for the 85, but maybe it's within the groups.
that's what I thought too, but then he put 17,
Okay.
which
Do you, so we can figure that out right now. I mean, that's not a
yeah.
big deal, but let me just do a double check here on my end here.
Okay. Sounds
Um,
good.
that's okay. Standard error. All right. So the quick search here didn't give me anything super useful. Other than it gave me a bunch of ANOVAs that we can do this with. So I don't have I mean, I want to make sure I'm best helping you here. I mean, um, let me just look a little bit more. Okay, so did you calculate that sum of squares error and the mean square? Like when did you cross these out, or did the teacher cross
This
this?
is like the teacher. Everything on the
Okay,
sheet on the PDF that I sent you is exactly what I was given.
so I'm looking at the standard error as just being the square root of the mean square error. That's why
Yes.
I'm okay. So
Yes.
this, like, to me, this is the square root of MSC. Is that right or
Yes,
not?
that's what I have.
Okay, that's where I'm. So we can find the mean square error here. You take this large number here, 1003119.4, subtract 116,537.1 to get sum of square error. You need the degrees of freedom. The total is big N minus 1, and then error is N minus K minus 1, I believe.
Yes.
Or is
So
it N minus K?
it would be like
Oh, it's N minus K minus 1, yeah.
84 for the total because now we took the 85. So I don't know how we got 17. But the 85 would be the C total and then 80 because
Yeah, so in
80
your problem, N is 85. There's 5 groups. They're labeled 0 to 4, which is a little awkward, but that's what it is.
yeah.
And then you go from there to find this. So so if you've got a calculator handy, and you're allowed to use a calculator in this class, I'm assuming, like standard
Yes,
calculator.
like open
Okay,
calculator, no computer, but
all right.
everything else, yeah.
All right, so when I subtract here 6537.1, so the first thing is the sum of square error is 886,582. You can do that pretty easily.
Yes.
And then you're going to divide that number by 80. And that's this other number. The MSC here is 11082. I'm not rounding, but you can round if you want.
Yeah.
And then you take the square root of that number, and that's the 105. So the square root of the MSE is the 105.27. Okay, so that's it for SC. SC is just the square root of MSC. It's this number in the table here.
Got it. Yeah. Okay.
Okay,
Yes.
that's it for number 1.
Okay. Oh, wait. So we told. Oh. Because like the properties of ANOVA, so like your root mean square error is your standard error of X bar.
Yes.
Got it. Okay.
Or mu naught. It's the standard error of the population estimate, mean estimate of the population.
Yes. Okay. That makes a lot more sense. Okay. And then
So
okay,
can we move to 2 or not?
yes. Yeah.
Okay, so it'll take me a little bit here to get kind of caught up to what you
Yeah,
guys
no
are doing
worries.
specifically, but rest assured this is something I'm very familiar with. For 2, there's kind of this awkwardness of I'm not really. So typically in an ANOVA, your null hypothesis is that mu0 equals mu1 equals mu2 and so on. Okay.
Yeah.
And then your H1 is that at least one of the means is different. Have you been seeing that?
Yes.
Okay. So that's where I'm sort of like leaning towards C. But here's the thing, this confidence interval, the way it's written, do you see how it only includes positives?
Yeah.
So since it only includes positive, like here's 0, and then your confidence interval is over here, 768 to 869. Because 0 is not in the confidence interval, to me, it's used to prove A as being the what they're trying to show.
Yeah.
Okay, and that's where I'm a little unsure here about how to tell you to proceed. It's sort of like this question is written backwards. Maybe you have more information from class.
So yeah, in class, what he said is we're gonna see a question like this on the test, but instead it's less so testing like it's more so testing the answers than the question, because basically what he's just trying to show, I think what he said in class was that with ANOVA, you are testing a certain number or not that number in like a confidence interval. So it wouldn't be greater than or equal to or less than. It would just have to be equal to 0 or not equal to 0 or equal to 5 and not equal to 5.
That's true. So in an ANOVA, you only care whether it is different, and that's what C is. C is saying
Yes.
different, which is the typical alternative hypothesis in an ANOVA.
So that one I like understand. That one I get, I think.
Okay. Okay. So do we need to talk about number 3?
Let me look really
Let me
quickly.
snip it in here.
Okay, no, 3 is just taking the average. So that one I understand.
Okay.
Because for like you go to level 3 on the table and then you're finding the mean, which is just you take the lower 95% and the upper 95, find the middle value,
And you find the average of it. Yes.
and
Yes.
then you're there.
Yes.
Um,
Now, one of the things that's not here in this table is the T-scores. I don't know if that's probably intentional, but the T-scores are not given for each of the levels.
yeah.
And the T-score is it's the mean divided by the standard error.
Okay.
I don't know if that's upcoming,
Good
but
to
usually
know.
it's like right there's the T values,
Yeah.
T-scores. Okay.
Okay. And then for the null hypothesis being tested here in the ANOVA table, I think that's just broad of like mu hat, like not.
One of the things, I guess, is there like a prompt for this, or is there just nothing?
No, I am so confused by this class sometimes.
Yeah.
No prompt. Just
Because it's typically something like, we want to know whether all the airlines have the same price ticket from Philadelphia to Phoenix, and
okay.
it's like Delta is 500 and Southwest is 600, and like
Let me
there's usually something that leads into, because we don't even know what they're doing.
it's something he was talking about bread in class. I think it might be like the amount of potassium bromate to bread.
Okay, so basically the this line right here tells you in words what that is,
Yes.
but it doesn't tell you, like, you don't know anything other than the mean. Like, it's like mu0, mu1, mu2, mu3, mu4. That's what I was showing you here. They're all equal, but sometimes you have to give like a context, meaning
Yeah.
like you just said, the potassium bromate ratio
In breads.
in bread. Because what I don't think is sufficient is just to write mu0 equals mu1, mu2, mu3, mu4, although it may be, because there's 5 levels, there's 5 mus.
Yeah.
Maybe that is sufficient.
No, I agree. I took stats in high school and loved it. My teacher was incredible. And then this is just such a different way of approaching it that's like trying to learn it.
So statistics is taught in typically like a math department, a psychology department, an engineering department, even like in physics. I mean, you get like many different ways of teaching the same subject, and
Yeah.
you're just at the mercy of the instructor, unfortunately.
Unfortunately, but yes.
All right, so five is asking for our MSC.
So wouldn't that just be the same as number 1 then?
That's what I was wondering. The standard error. Maybe it's one of those things where they might ask you for the standard error of mu naught, or they're going to say our MSE. Maybe double check that in class, but that's how I interpret that.
Yeah, me too. And then 6, which one of the following is required? assumption for fitting in ANOVA. It's like there's no we'll just skip 6.
There
That
are
doesn't make
just a quick comment though, is there's I'll just say
Yeah.
there's like 5 sort of requirements, and there's like normality of the data, independence, things like that. And these might be like on a PowerPoint slide somewhere.
Yes. I do. Maybe I didn't take a picture of it in class, but we did discuss that. So that's definitely in a PowerPoint, and I can have that during the exam.
Okay.
Oh my God. Okay, wait. 7. I have the answer as mu naught.
Yeah, if you go back and look into the table, they're just saying it's right there
Oh,
in the table.
oh, that's okay. Perfect. 8, the error degrees of freedom, that would be 80. And like we already kind of had to calculate that.
Yes. Now just one more, I'll just make another point here about these
Yeah.
tables. Like this one is kind of nice because they're telling you this. What they sometimes do is they don't give you anything in this row, and you need to know that the error comes between the variable and the total.
Got it. Okay. And then wait, let's see. 9, the estimate for the standard error for level 1 and level 2 are identical. Okay, in class, he said that they're identical because the sample size is the same.
Okay. You mean you can get the standard error? That's why I'm a little unsure how to
So
go ahead.
yeah, no, I just wasn't clear on why. Like I understand when you can see through the markings that they're the same.
Right. So here's where I think I'll just comment on this part right down here. It's a pooled estimate, meaning they're saying they're the same
Yeah.
because of that. Now, are they in reality? No, but
No.
that's what it's saying here.
Okay, wait, that yeah. Makes so much more sense. Estimate. Okay.
Is that clear, or do you want more
Yes,
commentary on that?
that is clear. That I understand.
10.
And then F ratio, I don't know what that is.
Okay, so it's another formula here. It's back from the table. Let me just resnip in the table. That'll help you when you see this on the real test. There's more than one way to calculate it, but the F ratio is this number, the first mean square number. So mean square, I can't remember what they call this one. I don't want to say K, but then it's over MSE. MS, I feel like K is right, but it's, so in your problem, it's the 29134.3 divided by the 11082.
Over.
Let me get the right.
Oh, got it. Okay.
So they call it, they say MST, but that's not right. I guess that's what they use in books, but it's not like this one that's missing. It's the
ratio between them.
yeah.
No. Yes.
But that doesn't look right either. So let me just double check this. No, it's MSR. That's why it's not looking right. It is, sorry, it's not T, it's MSR. That's why it's not right. MSR is this 29134 over that. We can just double check that real quick that it gives the 2.66. I mean, it should. Yeah, that does work. So it's this top number divided by this bottom number.
And what does the F ratio like actually show? Like what is that number?
So F is like Z, T, F. These are all for lack of better words like it's the number you use to compare or look up in the table to get the area under the curve.
Got
So
it.
the F distribution looks like this. So that F value is somewhere and you calculate the area in the tail like you've been doing over and over again for.
Is the F curve always like right skewed?
Yes.
Okay.
That's kind of a multiple choice question. It's that the F values are only positive, or I guess it could be zero in a weird situation, but they're always greater than zero.
Okay, that makes sense. And then okay, then it says what is for 11, what is the distribution of the above F ratio?
I'm not sure to answer this because it is the F distribution.
Yeah, with distributions, that's something I think I'll ask that's like specific to him.
Okay.
So I'll ask in class because the way, like I understand like
It's like you just asked
normal.
me, it's missing a word. What is the shape of the distribution? Or
Yeah,
what is the area? It could also be asking about the area in the curve, which it did not. Like it normally asks for the p-value right there,
yeah.
which this one does not.
So
Yeah.
I'll ask about that one in class. But then for okay, when we have multiple hypotheses all at level 0.05, the probability of at least one type 1 error is equal to that one we didn't do in class and I'm confused on.
Okay. So the overarching thing is like if your p-value is less than alpha, and this is just review. If your p-value is less than alpha, you reject H0. Okay. Now there's this thing when you're doing an ANOVA where when you're doing multiple comparisons, you take your alpha level and you multiply by the number of levels. So you're taking your 0.05
Yes.
and multiplying it by 5. And this is the kind of thing to check in class if that's what this is actually referring to.
Okay.
And this is why in the ANOVA, you can only claim that one is different. You can't claim that, or at least one is different. You can't claim which one is different without going back and doing the individual comparisons.
Got it. So like the purpose of ANOVA, like practically, could you say it's similar to a chi-square test in that like it's kind of a first step analysis to check that there is something to look further into?
I would agree with the last part of that, because the chi-square test is used to check on whether the distribution matches, whether you think your distribution matches
Yeah.
the information in the table. Here it's strictly to determine if there's a difference in the group
Okay.
or
Got it.
between the groups, and you don't know which one if it is different, which I think is kind of frustrating because all you know is there's a difference. You just don't know which one it is.
Okay. Got it.
You would never do this, but an ANOVA can actually also be used for 2 groups. But
Yes.
you would go back and use a t-test for 2 groups rather than an ANOVA. It's overkill.
Got it. So would the probability then just be 25?
Yeah, I believe it's 0.25. This is a question to ask in class if you have. It's
Okay.
just to say, do we always
Yeah.
for this question, are we multiplying the alpha level by the number of levels, or K, I guess alpha times K?
And that gives for type 1 error.
Yes.
Oh, because that would be, yes, got it.
Yes.
Okay, that makes sense. Okay. And then 13. I don't know what those are.
So these are called the post hoc tests. These are the ones you do if your p-value is less than alpha, because you know there's a difference. So you then do the individual comparisons. You then compare mu1 to mu2 and mu1 to mu3 and mu1 to mu4 and so on.
Got it.
Now, in terms of this though, I don't understand. I mean, I've never even thought to ask this question, so I'm not sure, because it's like you choose one or the other, and it's usually just in software. Like it's usually just a box you click. You say, okay, I'm gonna do the one or the other.
Yeah.
Trying to look it up here. See what's going on here. If the bond for any. All right, this is kind of interesting. You probably have to follow this up in class.
Okay.
But the answer here is, I believe there probably is a difference just the way it's written, but it says if pairwise comparisons are of interest, and that's what I was showing you here.
Yeah.
A Tukey has the edge. Okay.
Okay.
If only a subset of pairwise comparisons are required, the other one may be better. I know that doesn't answer your question,
But context.
but maybe it would help here.
Yeah.
Actually, the last thing this reference I'm looking at says is that no single method is best, which is true. Like there is no, but to answer your question here, I mean, I don't really know. I don't know
Yeah,
why.
no, that's me neither. So that's okay.
All right. 14 is referring to a
Yeah,
question.
that we can just skip. I have the book, but just
Okay.
I don't know what questions. So
All right. So now we're up to some multiple choice questions. Does that sound about right to you? Okay.
Maybe some questions with the actual context now.
All right, we'll see.
Okay,
right.
14. Okay, or 15 learned in class. Let's see if I can explain it to you in a way that I maybe makes sense. So because actually I have no clue. I think I learned a different one.
So this looks really complicated, but it's saying y equals b0, which is the intercept, plus a coefficient like b1, x1, b2, x2,
yes,
b3, x3, and then there's always this error term. But basically, this is a multiple linear regression equation. This stuff on the right here says that the error is normally distributed with mean 0, that's mean, and variance sigma squared. But that's kind of a standard thing.
Yeah, so when I first see this question, like even in class, I was like, okay, it's probably B, which was right.
Okay, so we can say for sure that they're independent. Okay, that's reasonable.
Yeah,
but not identically distributed. So I think the reason that they're saying that is because the error I is n0 sigma squared. I guess these are going to change. I'm not sure what this IID refers to. That might be.
It's like an independent random variable, I believe.
Okay, and you're sure it's B? You're not.
I'm sure it's B.
Okay.
That I have.
Right. Okay. Okay. Let me just do a quick search to see if I can find any more information that might be useful.
Independent, identically distributed.
Yeah, I mean, for sure they're independent because it's, this would be like, if you're looking at a home, this is like square footage, this is, I don't know, number of bathrooms. And,
Yeah,
and then the distribution means that they all have different variances for simplicity, like square footage, if you're in a 2,000 or 3,000 square foot home, the variances are going to be much larger than, say, number of bathrooms in the home, which is,
yeah.
much smaller.
That's what I was thinking, like just like common sense was like, okay, it's probably
Yes.
B. Okay, yeah. So then that makes sense. Yeah. Okay. Yeah, I understand that. And then for 16, the residual standard deviation when fitting the model has the same units as
Sometimes you have to just go back to what the units are standard error if you don't know. Like, if you just forget about this equation, just what is it in general? Like, which ones do they refer to? Is it the
well, standard error is standard like sigma over root n.
okay? So standard error, it's like whatever the roots are of sigma in that case, right? It's whatever that
Yeah.
is. Okay. Now in this problem, it's the residual of it's the residual. So we now need to look at what the residual is. R is y minus y hat. So it's really the units of the output. What are
Yes.
the units of the output here?
Log y.
Or what is the y? Yeah. So I'm sort of leaning towards something like this.
Yes, I have written down on notes y minus y hat with an arrow pointing to that saying same units. So
Yes.
okay.
So the reason I brought up the standard error is like just as a reminder where like whatever it comes from something. And so in this
Yeah.
case, it's kind of deceptive because it's saying residual standard deviation, but it's really the residual that we're measuring
Got it.
for that.
Okay. Yeah, I understand that. And then okay. 17 did not look at. Oh, okay, in class, I think I had to miss this class, but going over partial versus marginal slope, I am confused on those.
All right. I'm gonna look here because the like when I see partial, I think of calculus, partial derivatives.
Yeah.
I've not seen this used in the context of statistics. What a quick search reveals that the partial slope is less than the marginal slope. I don't have a good explanation though for why that is. Have you taken a calculus class or two?
I've taken like Calc AB in high school.
Okay. So there, like I guess I would want to know, I need to know more about what this refers to. So partial means there's more than one variable and you're keeping the non-variable of interest constant. I don't know why though it would be smaller than this in this context.
So I have okay, the one slide that is on it,
Mhm.
it says partial slope, the BIs for I equals 1 through K. This actually, wait, I'll actually email this to you. Next semester I'm like planning on making all of my classes very specific to who teaches it.
Yeah, they don't teach that you actually get to choose who you get the class with, and you can really makes a
Yeah.
difference.
God.
All right, so
But
this one's somewhat useful. Here's probably some of your slide. It's saying that the part of the predictor variable independent of other predictor variables and the criterion is its partial slope. The partial slope, this is the part here. Each partial slope represents the relationship between the predictor variable and the criteria holding constant all the other variables. So basically they're saying like, if you only care about that one variable and all the others are constant.
God.
But why is it smaller? I don't know. So you said you sent something over. Take a look here.
Yes. Like that's all the information on the slide.
Yeah. I mean, these are good questions to ask. You know, shows that you're
Yeah.
engaged. If you haven't gone to the office hours yet, might be a good one to go to. You might get a much longer explanation than you want, but at least you know they'll know you care.
Yes.
I'm not sure what you sent over really isn't useful for
Yeah.
answering this question because it doesn't talk about magnitudes of these things relative to the other. So
Yeah.
let's we'll just have to move on here to
All good.
18, I guess.
Um,
And just because the lessons are 50 minutes, so we've got another eight-ish minutes here.
sounds good.
So if there's something else you for sure want to get to, just let me know. Otherwise, I'll keep going in order here.
Yeah, I think order just makes sense. And I'll probably, because I have these tests coming up, I'll probably just like keep scheduling
Sounds
throughout
good.
this week.
Okay.
Okay, so if the confidence interval for the marginal slope of x includes 0. Okay,
So
for the
so this is a
marginal.
more basic question, is if your lower confidence limit and your upper confidence limit, if 0 is in the middle, what they're asking what you do. And sometimes it's easier to look at a simpler example, like because your B1 is 0 and your your null is that B1 is 0, your alternative is B1 not equal to 0. If 0 is in the confidence interval, do you accept or reject H0? Reject or fail to reject H0? Do you remember that?
We failed to reject
That's right. So it's either A or B.
because it's in it.
Yes, because it's like we don't know whether it's a little bit bigger, a little bit smaller. We just know that
Yes.
it's for sure, and that get rid of those two. Now the stuff on the right here, this is asking specifically for X1. So I'm leaning towards B because it's specific to X1. But that's my only
Yeah.
justification for that.
Okay. But that makes sense.
But then I don't understand why this isn't X1 E1 also. So I might ask that in class.
I can do that.
Maybe there was a mistake in because A is the generalized form of all of them. So I think that
Yeah.
might be just a typo for why that is there, just copying and pasting it. The instructor did.
Yeah. Okay. Yeah, that makes sense.
All right,
Yeah.
19.
Okay. Yes.
Are you guys using any software in this class, like R,
So
Minitab?
we're using Jump, but for the exams, like we don't. It's just on paper.
Got it.
So it's not like I used Jump in high school, so I'm pretty familiar with it. But we can't even like use that during what
Yeah.
determines our grade. So it's a lovely class.
Yeah. This is this is a tough class. A lot tougher than a lot of the stats classes I see working with students
Yeah.
around the country.
And also it's business stats, but none of this is like,
I wouldn't classify this is more traditional classical stats than
yeah,
business stats.
yeah. I was like so excited, but that's okay. It's okay. Gotta get through the next like 6 weeks.
Yes.
Okay. If an equation uses the reciprocal of the explanatory variable, as in that function,
So they're just referring
then
to that there.
yeah. the intercept B naught gives us,
So sometimes it's good to go back to what does B naught is Y when X is 0 in
is
general,
zero.
like in the normal case, okay?
Yeah,
And so that excludes D because we're talking about the reciprocal.
yes,
The reciprocal of this. So you can think of X being 0 over 1. So the reciprocal is like the equivalent of 1 over 0.
yeah, which,
So which is that? And it's it means that it's not exactly 0. Think of it as like 0.00001. So 1
yeah,
over that is a really large number.
number. So C
Yeah,
then,
I believe it's C. Yeah.
okay. And then Y, oh,
I've
so
not
with like the expected value things, like, that's just like not right.
I'm surprised that it's here because the only time expected value comes into play is when the regression equation is not significant, and then you use
Yeah,
the mean of Y as the expected value of the regression, which it's basically saying that because your data is uncorrelated, we just take the mean every time.
yeah,
So if so X very large is out of scope because we well, I shouldn't say it that way. I guess this again, it's good that you're doing this early. I'll just keep saying that because you can go find out like why this is here
yeah,
if it's not, doesn't get answered, you can maybe find
yeah.
out.
No, I can definitely do that. But C, I think C is right. Well, like it is. So, okay,
Let's take a
that
look
makes
at
sense.
take a look at 20 here.
20. The R squared in a transformed regression model when the Y has been transformed to log Y. So Y R squared is like a measure of correlation.
Yeah, it's
Like,
really a percentage. It's like how much of the output
meaning
variable is
it's
predicted.
unitless,
That's
right?
exactly right. So
So it
converting
doesn't
it,
matter what.
yeah,
Got
usually
it.
transforming it, it's still unitless.
Okay. Yeah, that one I get. And then 21, doubling the sample size used to fit a regression can be expected to reduce the standard error of the slope by about. So standard errors, again, the standard deviation over the root of n.
Yes.
So if you were to increase, let's say like, okay, root of 100 is 10. Let's say we double the sample size. Root of 200 is not 20, so it's not 50 and it's less. So it's either 30 or none of the above.
Well, okay. I think remember it's when you're making a comparison. So it's the like how are these two things related? And it's like
Oh, yeah, I
saying
wouldn't throw much
it's
that up.
like you just said that it's 1 over 10, and then I believe you have to say 1 over 2. It ends up being 1 over 10 root 2. So I think
Yeah.
1 over root 2 might be how to do this. Let me see if that number is actually.
Oh, it's around 70.
Yeah, it's about 70.
Oh my God. Wait, that actually makes so much sense.
Yeah, you gotta be. It's like I don't know if you took a physics class where it's like if you double the mass or you increase the radius.
No,
Like what?
no physics.
Okay. Well,
I'm I'm studying philosophy, politics, and economics, and at the beginning of this year, thought I would throw in a stats minor. After this, I do not believe that will be happening.
well. If you want my opinion, you actually know this stuff much better than